Hey everyone, and welcome back to the channel. Today we are checking out something a little different, the FNIRSI ERD-10. ERD-10 is a brand new 3-in-1 detector that brings a whole new level of versatility to your toolkit. It's designed to measure electric fields, magnetic fields and RF radiation power all in one compact device. Whether you're working with high voltage equipment, dealing with electromagnetic interference, or just curious about radiation levels, the ERD-10 should have you covered. I'm excited to see if this could be a game changer for your workbench. It promises to offer professional level readings with ease, and given the price, it's a great option for both pros and hobbyists, if it works. Before we dive in, just a quick note, FNIRSI sent me this device for review, but no payment was involved to produce this video. I don't have to stick to any guidelines and all opinions are entirely my own. As always, they will see this video at the same time you will when it's published on YouTube. A thank you to FNIRSI for sending this device for review is in order, and of course, a huge thank you to you, my viewer, that sponsor the channel just by using the affiliate access links on the screen or in the video description whenever you want to do your shopping on AliExpress or Amazon. You will pay exactly the same, but by using these links you are keeping this channel going. For your support, my big thank you. Alright, let's take a closer look at what makes the FNIRSI ERD-10 tick and whether it's worth adding to your toolkit. Looking for fast, reliable manufacturing services? PCBWay has you covered. From high-quality PCB prototyping and assembly to precision CNC machining, they deliver professional results trusted by engineers worldwide. But here's the real highlight: PCBWay's advanced 3D printing services. This month they are offering amazing promotions on TPU flexible printing. Perfect for durable, flexible prototypes, wearables and custom designs. Whether it's PCBs, CNC or cutting-edge 3D printing, PCBWay brings your idea to life, affordably and fast. Check out PCBWay today and take advantage of their TPU flexible printing deals. Let me now show you what comes in this box. The ER10 is delivered in this retail box. Pretty good looking, as FNIRSI nowadays ship every device. We have electric fields as detection, magnetic field and RF radiation power, I think. Okay, let's see what comes inside the box. We have these quality control cards, normally shipped with the FNIRSI devices. And let me take this out. Do we have anything below? Yes, we have. Okay, so let me take this, and we have a cable USB Type-C to USB Type-A for charging and firmware upgrade, and the user manual in Chinese and English, and that's it. This is the kind of manual that FNIRSI nowadays does. A lot of information, color, photos, infographics, pretty well organized, so yeah, very nice work. And in terms of the unit, let me open this bag. Okay, here we have it. In terms of first impressions, we have a pretty big screen. It's LCD, I believe. Yeah, some clicky silicon-like buttons. Let me power this off. It's not the time yet. On the right side we have the socket USB Type-C for charging and firmware upgrade. And on the left side we don't have anything, neither we have it on the bottom or in the top. In the bottom we have this kind of gap. I don't know if it is for a sleeve, but it's not delivered with one. But yeah, and in the back it seems to have two sensors, one on the top and one this square below. In the bottom it says that it requires 5 volts 1 amp charger and it has a battery of 1000 milliamps hour. We have some indications in the back. For electric fields it will be able to go from 1 to 1999 volts per meter. For RF it will be able to go from 0.1 to 999.9 milliwatts per square meter, and for EMF, magnetic field, it goes from 0.1 to 1999 mg. Yeah, okay. That's it in terms of the first impressions. Now is the time to power this on and see how it works. Let's do that. It's in the bottom one. Okay, the first thing that we need to do is select the language. Let's go with English. Okay, and this first screen has a lot of information. We have from the left to the right, the A is for the auto shutdown activated. We have also the hold button and the battery indicator. The battery the hold seems to be already selected, but if we press, you can see that it is selected on yellow. The first value, accompanied by a gauge on the left, is the electric field intensity, and the values are in volts per meter. And we have the second value, that is magnetic field intensity, that is translated in microteslas. On the bottom, we have the radiation power, that gives you values in microwatts per square centimeter. And lastly, we have the temperature in this room, that is quite hot right now, and I need to power on my AC, but it's 28 degrees Celsius. In terms of this main screen, that's it. Let's see what else we can do. We have the hold, right key doesn't do anything. This one also, modes. On mode we have a graph for the electric field values. We have it on graph. We still have the temperature on the top and also the auto power off or auto shutdown. If you go to the right, it will show you the graph for the magnetic values. In this case, I don't have anything registered yet. Okay, that's it in terms of this option. Do we have another thing? We don't. Okay, it seems that in terms of the screens, that is what we have. Let's see what we have in terms of setup. Okay, so in this first screen, we can define a threshold for the micro Teslas. In this case, we have 0.40 until it starts beeping. If we go to the second option, it will set also as 40 volts per meter as the threshold for beeping, for the alarm that we can set. And we can set the magnetic field unit in micro Teslas, or I don't know this one, so you can also use the mg. Then for the automatic shutdown, that's the A that I mentioned before, we can have 5, 10 or 15 minutes. And for last, we have the volume setting. Let's see how we can do this. Okay, okay, enter. Let's put a little lower. I like beeps, but it has to be a little lower. We have also the brightness. Okay, it's at the maximum and we can see perfectly the screen. Normally in the camera we have some difficulty to see the screen with the maximum bright, so very nice. The language setting, we already saw that it's Chinese or English, and we have the style setting. What is this? Okay, outdoor mode. Whoa, this is a high contrast mode. Let's see how the information is displayed. Okay, this might work much better in the outside, yeah. But for inside, I prefer to keep the other one. Makes more sense to me, but it's nice to have this kind of outside modes. Let's see. Okay, oops, no, like this. And finally, we have the factory data reset. Normally I will do this, but I just changed the beep level, so I will not do the factory reset, otherwise I will have to set the beep again. And in terms of the menus and operation, that's what we have. Now let's do some testing on this. Okay, for the testing part, I'm gonna use this ERD-10 ER-02. That's the only device that I have that is able to also do some testing in this area, like the electric fields and magnetic fields and so on. One thing that is sure is whenever a mobile phone is connecting to the grid in terms of the mobile data or Wi-Fi, the levels of electric field energy and also the radiation power increases. So let's try first to measure the electric field. Okay, let me just change the mode to voltage meter to be on the same pace of the other one. And let's start by connecting to Wi-Fi to see what happens. Let's connect. So it's recording about 20 to 30. It has a peak on the 30. This one is stable on the 24. The values are not quite the same. Let's bring it more close to the mobile phone. Maybe change positions. I have to keep this open to see if the values change. Okay, it's around 20 in both devices right now. Maybe the sensors are in different places. So we have 23 in this one and 20 on the other one. Seems okay. Let me now disconnect the Wi-Fi. Yeah, and connect the mobile data. Yeah, so it seems more or less the same value, so I might say that they are accurate, at least they are aligned one with the other. So now I will change the scale of the ERD-10 to milliwatts per square meter, and we have some information already. Oops, let me put this again. It's registering about 8 to 10 milliwatts per square meter. And in the bottom, we cannot see the same information, or it's 3.228 microwatts per square centimeter. This is a different scale, obviously, so it might be harder to see. But even if you multiply by 1000 to change the scale, the values doesn't seem to be exactly the same. This one is always lower. Not sure if this is the same thing or not. But okay, let's change this to Wi-Fi. Every time it connects, it gives a huge boost in terms of Wi-Fi. Okay, and this one is not doing the same. If you disconnect, it should be again to 50 milliwatts per square meter. Yeah, it gives a boost on disconnecting, and now it's not showing nothing. If we connect the data mobile, you can see also a spike in here, but yeah, doesn't seem the same in this side. In terms of radio frequencies and everything else, RF, it's not the field that I love in electronics. It's not my area, but at least if you know what all this means really, I hope that this demo will be able to give you some information. Okay, with both Wi-Fi and data mobile connected, also we have this around 10 milliwatts per square meter, and here it's showing 3.2 microwatts per square centimeter. Okay, with the mobile test, that's it. One thing that I know, even if this is not my area, is that the magnet itself will not create a magnetic field. Okay, so if you want to see a magnetic field, what you have to do is to have two magnets and create movements within those magnets. As you can see right now, we are having like 1 to 2 microteslas. 6, 8, it depends, because this is nothing that I can control. it will create these values. I don't know where it is, the sensor of the Eric Hill. Well, I don't know this one, but let's see what we have. Okay, it will create about 1 to 2 microteslas while doing this. Okay, this is just a movement. If I approach the magnets one to the other, the values will increase. As you can see, it is able to go up to 3 microteslas. Okay, and it seems to detect if the value is correct or not. I don't have equipment to make sure that the values are accurate, but at least it detects, it passes the 0.40, I believe that's what was defined initially, and this one also, it detects around the same values when you are doing this. As faster you do and closer, the value will surely increase. Okay. So it seems to work. Let's move on. Let's go again to the electric fields. We have obviously electric fields whenever you have an extension with power or a cable with power. So let's start by seeing if you bring it close to Eric Hill, if it will give you something. It will give you about 250 volts per meter. And if you bring it to near the FNIRSI, it will give you also around 200, 300 volts. It depends where the sensor is, but around 300 volts per meter also. Okay, if I do it the same way, yeah, it will always pass the thresholds. So it seems also to work. It's a bit over the value that we have in here. Well, this one is it's going also near the 300. So yeah, I take it as good. 200 and yeah, it's very near. It depends on the sensor position. Okay, that's good for me. And now it's teardown time. Okay, here we have it. It's a simple board. It has a 3.7 watts hour and 1000 milliamps hour battery. 3.7 volts, very nice. Okay. And what else? Well, in terms of the PCB, we don't see much here. We have only this processor in here and 3 ICs that worth mentioning. We will see on the microscope what they are. It seems that we have a sensor here on the top and a communications connector here on the left. Okay, seems that's it for now. Let's put this under the microscope and see what we have here. We have the board already under the microscope. We can see that on the top we have this sensor connected to this inductor. Okay, and the first 2 ICs that we have in here, let me see if I can show you, are those GS8092, and these are basically 300 megahertz CMOS rail-to-rail output op-amps. Okay, we have 2 of them, and here on the left side we have a microcontroller. It's a Numicro M2351 series, and this is basically an IoT controller. It is based on ARM Cortex M23 with 64 megahertz frequency. Okay, and obviously we have always the Scratch main controller, and on your left side you have the communications connectors. Okay, and we have, I think, in here a LB33. So this is a Micrel 150 milliamps low noise LDO regulator. Well, this is the LB, and we have also in here a high efficiency 1.2 megahertz 2 amps step up converter. It's the SB6284. And finally, we have an IC that is almost always present in these small devices. Well, I'm talking about this one. It's the TC4056A, and basically it's a single lithium-ion battery with constant current, constant voltage, linear charger. And it is pretty common in these small devices. It is here normally near the USB port. In the front we have only the connector for the display and the buttons, nothing else. And yeah, that's it. Let's assemble this. So let's sum everything up. The build quality is good and in line with other FNIRSI equipments. The body feels sturdy and well put together with a compact design that makes it easy to carry around or stash in a toolbox or drawer. The buttons have a nice tactile feel, the seams are tight and the device doesn't feel flimsy or hollow. So overall the construction doesn't scream budget device, and that's a big plus in this category. Now onto one of the highlights, the interface and display. The ERD-10 features a 2.4-inch color screen and it's genuinely sharp, bright and easy to read. The UI is clean and well organized. One standout feature here is the graph mode. It allows to visualize the real-time trends, which is super helpful when you want to track how EMF, magnetic fields or RF levels change over time. It's the kind of feature that usually is missing in devices at this price range, and it really adds to usability. Now, in terms of accuracy, the ERD-10 performs well. I compare its readings with Eric Hill ER-02, a similarly priced meter, and the values were consistently in line, especially for electric and magnetic field readings. The RF detection also works, but I have a lot going on here on my lab that can interfere with the values. It's not a lab-grade device, but it can definitely alert you to higher levels of RF activity from Wi-Fi routers, phones, or other wireless devices. Overall, the ERD-10 offers consistent, believable results, which is all you can really ask for a device in this price range. And regarding the price, the FNIRSI ERD-10 is currently selling on AliExpress FNIRSI official store for around 26 euros or $29, which is honestly quite fair considering what you are getting. At this price point, it competes directly with entry-level EMF detectors, but offers a more modern interface and extra features like graphing and multi-mode detection. It's a solid bang for your buck, especially if you are a hobbyist technician or someone curious about RF or EMF exposure in everyday environments. So wrapping things up, the FNIRSI ERD-10 is a feature-packed, well-built EMF meter that punches well above its weight. You get a great screen with graph mode, a user-friendly interface, solid accuracy in line with my other tester, and all at a price that makes it hard to ignore. Sure, it's not perfect. If you need precision measurement or industrial-grade sensitivity, this isn't the tool. But for casual users, makers, tech hobbyists, or even people just curious about EMF in their home or workplace, the ERD-10 is a fantastic budget-friendly option. It's one of those tools that's good enough to be useful and cheap enough to justify owning, even if you only need it occasionally. And if you want to buy a unit, please remember that if you use the affiliate access links on the screen or in the description to access AliExpress or Amazon, you will be sponsoring the channel without spending a cent more. A big thank you for the support and sponsorship. Also, not costing a cent more is your slap in the like button if you like this video. And if you are new here or just didn't subscribe yet, by subscribing it will help you to be on the loop with all the coolest equipment devices that hit the market and every week I receive and review here in the channel. That's it for today. Let me thank you for your time and company while watching this video. I hope to see you in my next one. But until then, take care.